talk about chemical and physical changes today as we begin the chapter 6 content. So the difference between a physical and chemical change. Physical change is a change which does not alter the chemical composition of a substance. The chemical change is simply one that does, right? A change that alters the chemical composition of a substance. So we're going to, for this portion of the lecture, we're going to focus on the physical changes that take place, and we want to look first of all at a specific example of that. But let me just, if you look in your books on page 161, you'll see a picture there that basically includes both of these processes in one picture, and it's a picture of this fire that's going. This fire is burning this big pot of water that's boiling. So the fire, what's taking place as the fire is and the wood is being burned up, that is a chemical change. All right. The boiling water, however, is a physical change, as that water is changing into steam. Right, the water is going from this liquid state to a gas state. And the kind of the rule of thumb as far as determining if I were to give you a process and you're trying to figure out if it's a chemical change or a physical change, the basic rule of thumb is a physical change is a change that can be fairly easily reversed. However, a physical change is very difficult or sometimes impossible. A chemical change is almost impossible to reverse. And so you have to be careful about it. You have to be thoughtful about it. Some physical changes, it may not be obvious. For example, if we take salt and we dissolve it in water, you can't see the salt in there anymore. It maybe appears to be a chemical change. However, if I boil that water and I capture the condensation that comes off of that as I'm boiling it, I can separate the water back out from the salt, because once all of it boils away, the salt's going to be left in the pot. And so you can actually reverse that process. So physical changes are reversible. Typically, chemical changes are not, right? So that's our big difference between the two. That's sort of the rule of thumb there. So let's talk about a specific physical change, namely temperature changes, right? Temperature changes, that's one of our physical changes. So when we talk about temperature, it's this typical type of physical change. It's usually measured in Fahrenheit or Celsius, as we know. Celsius is the most common, maybe not here in the U.S., but certainly in the scientific community and then around the world, Celsius is the most common. And so we have to know how to convert between these two, since those are the two common units that are used. And so degrees Fahrenheit is basically equal to 9/5 degrees Celsius plus 32. All right. So you're going to need to memorize that. You're going to have to be able to do that on the test. So make sure you know that formula. Now, if you're good at rearranging things algebraically, then this should be the only equation that you need to memorize. This was very easy to use. If I give you degrees Celsius, right, you just plug that in there and you can calculate the degrees Fahrenheit. But sometimes I'll give you the degrees Fahrenheit. I need you to go in the other direction, right? So in order to do that, you're going to have to know the formula for degrees Celsius. And like I said, if you're good at rearranging these things algebraically, you can easily figure that out. If we want to get degrees Celsius over here by itself, then we'll move degrees Fahrenheit, the 32 over to the other side. So degrees Fahrenheit minus 32 is equal to 9/5 degrees Celsius, right? And then to get rid of that 9/5, I would multiply both sides basically by 5/9. We'll do that over here as well, 5/9. And so the formula for degrees Celsius is 5/9 degrees Fahrenheit minus 32. Okay? If you can do that, then this is the only formula you'll need to memorize, and then you just solve for degrees C and you'll have this formula. But if you're not good at doing that, then I would recommend that you memorize them both. Okay? That's the formula for degrees Celsius right here, converting from degrees Fahrenheit to degrees Celsius. These two scales are based on, you should know this, they're based on physical properties. These scales are based on the physical properties of water. Namely on the freezing point and the boiling point, right? So we know the freezing point the freezing water, that is, and by the way, when we say freezing water, we mean ice and water thoroughly mixed. Thoroughly mixed. All right. If they are thoroughly mixed together, then they will always be freezing water, ice and water thoroughly mixed is always 0 degrees Celsius or 32 degrees Fahrenheit, right? And then these scales are also based on the boiling point of water. So boiling water is 100 degrees Celsius, right? Or 212 degrees Fahrenheit. So I expect you to know that, right? You need to memorize those as well if you haven't already. Make sure that you know the boiling point and the freezing point of water. Okay? So let's do a couple of quick examples just to let you use these equations here to make sure that you can convert between Fahrenheit and degrees Celsius. And so we're going to do example 6.1, which is on page 163 in our book. And example 6.1 says, most chemists define room temperature as 25 degrees Celsius. What is that in degrees Fahrenheit? All right, so remember we said degrees Fahrenheit, right, was equal to 9/5 degrees Celsius plus 32. So they gave us the degrees Celsius as 25 degrees Celsius, right? So what is that in degrees Fahrenheit? So we just basically plug in the 25 here plus 32, and when we 9/5 25 5 right there. So that's going to be 45 plus 32, and so our final answer here is going to be 77 degrees Fahrenheit. All right. 77 degrees Fahrenheit. Make sure that you always put your unit on there, right? Don't forget your units. That's the simple way that you would solve for degrees Fahrenheit if you were given degrees Celsius. So the next example here lets us go in the other direction. And I'm just going to leave this equation up here for us to use. It says the hottest temperature ever recorded as of March 2014 is 134 degrees Fahrenheit. So they give us the Fahrenheit this time. 134 degrees Fahrenheit at Furnace Creek Ranch in Death Valley, California. What is that in degrees Celsius? So they want us to give the degrees Celsius here. Death Valley, California. We went there one time, and we went all the way over there to that national park to see this little fish that you only find there in Death Valley. And we walked down this. It was a cool day that day. It was only 104 degrees. We walked down this long boardwalk out to where this creek was, where this little creek was, where you find these fish that are unique to this one place in the world, right? And the riverbed was totally dry. There were no fish. I was hot. Yeah, wasn't a good experience. But anyway, still a cool place. There were some neat sand dunes there. How do you convert from 134 degrees Fahrenheit to degrees Celsius? Well, again, you got to be able to rearrange this equation, right? You have to be able to say that degrees Celsius is equal to 5/9 degrees Fahrenheit minus 32, right? So that's our formula for that. Now we're just plugging in the values. 5/9, 134 minus 32. So that is 5/9 times 102. I was right. 102, right? That is divisible by 9 there. 102 is divisible by 9, but I don't know what it is offhand. Basically, if you punch this in your calculator, you get 56.7 degrees Celsius. All right, so that is our value as we convert from 134 degrees Fahrenheit to Celsius. All right. I will see you shortly as we talk about another physical change.